Okay, let's continue where we left off last time. If you haven't seen part 1, you will need what we made there. That's the circuit, of course. So today we're going to write the code to the circuit. It's useless to have the circuit unless you have the code to it, and it's useless to have code unless you have the circuit to it. You get it? They work together. So you'll need the Arduino IDE for this. If you have watched that video, it should pop up somewhere on the screen right now. Info somewhere. Enough talking. Let's just get right into it. Okay, so let's just get right into it here. Just like last time, I got the Arduino IDE open. Well, there was no last time. Little joke. So there will be a few comments around here. I'm not really gonna write them, but if you do download the code, the comments will be there. So I'm gonna, before we start doing code inside these little functions, which I'll explain soon, I'm going to create two variables. You probably have never heard of those unless you're a little bit of an experienced programmer or even just a beginner. Those are some things that you usually learn very early. So the constant is kind of like some data with a name. So I could have my number of apples. Like that there isn't some data, but it's a place where you keep the data. So to make a constant though, a constant means it's some data that can't be changed. A variable is some data that can be changed. So I'm going to create actually 3 constants. So to create a constant, you go const, that way it knows that it's a constant. It's short for constant. And then you give in the data type. Let's learn about data types here. So a data type, here's the different kinds of data types. You have int, which is a number usually from a negative 255 till 255 positive. And I'm going to go ahead and delete that. Now we have long, which is a very, very big number. And also we have these two things you can put before of the data type, like signed, which means that it's only negative numbers. Unsigned means only positive numbers. So if I want to have an integer with only positive numbers, that's actually something that you might want to do, because what it does is instead of going negative 255 to positive 255, what it does is it does 255 plus 255. And let's see what that is. 255 plus 255 equals 477. So that would be 477, which is bigger than a normal int. So an integer, a normal integer, is negative 255 till positive 255. Now an unsigned integer, that's what int actually means, integer. If you're a little older and you know about numbers and you're in math a lot in school, and that's one of your subjects that you like, you should by now know what an integer is. It's just a number. So if you have learned about bytes, which we'll cover in another video, a byte is 8 bits, which makes up a combination which can actually do a whole output of 255. So an integer is actually 2 bytes. A byte is 1 byte, of course, which means 0 to 255 positive. Now an unsigned int, just like we just calculated, 255 plus 255, of course, like that might be a little easy for you, is 510. 510. 0 through 510. Now, what does that mean if it were a signed int? It would be the exact same thing, but it's signed, not unsigned. So you go signed int, but that's not going to be 0 through to positive 255. It is going to be negative 510 to positive, to 0, of course. 0 is actually a positive number. even though it's kind of like a mix. I don't know why some things just don't make sense in math. To me, at least. 0 might be a little bit like negative 0 and 0. They're both the same thing. But still, well, I'll just do it. So an integer, a normal integer, is negative 255 to positive 255. An unsigned integer is positive 0 to positive 510. A signed integer is negative 510 to negative 0, even though it can be positive 2. I'll just do negative for now. So then that should mean that the exact same thing should happen with long, right? Long. Well, yes, but it's not exactly this. It's a humongous big number. You might want to look that up. So, const int, because this is going to be a normal number. It's not too big, not too low. And we're going to make on equals 1, or high. High equals 1, actually. It's actually a variable that's already created in Arduino that actually means 1. But you can do it like this. I don't actually want to do that. You can do the same thing with off. So on equals high. Low equals off equals low. So what you're going to do to do this, you're going to go const int on equals high. Const int off equals low. And don't forget to put your semicolons after these things. I'm going to comment that out because I don't really want that. But it'll be there in the actual code that you'll download. But you can always comment it out and change the numbers. Change from on to high and low to off. So what we're going to do is we're going to create a third one. And remember what pin it was? Well, we're just going to write const again, int, because it's a number. And we're going to call this the LED equals, and then you write the pin. Now, if it were a super duper 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 loud beeping thingy, which is actually a piezo, but it doesn't go that loud. But then you would write piezo, or whatever it is, and then you could write the pin number. So this could work with an LED, a blinking LED, or a blinking piezo. No, it just makes a sound at 1 second and then turns off for 1 second. Turns on 1 second. This is pretty much what this program even does. So what you're going to do is you're going to give them the pin number. In this case, it's 13, of course, so then you put your semicolon. I'm going to keep this. If you don't want it there, comment it out and everything. To create a comment, you just put 2 slashes. Not 1, not 3. Well, 3 does work, because it pretends that comment there is just like some weird word. But a comment is actually just means you can have words. It doesn't need to be code. Like you can have, this is a constant. This is a constant variable. Like you can do like that. Sorry about my spelling there. So constant LED equals 13. Now, what if I put it on pin 15? Well, that's not a thing. What if I put it on pin 10? I just write 10. 13. If I put it on pin 5, write 5. And if I have 2 LEDs, remember I edited the code a little bit last time? LED 2, so I can have LED 1. And remember it was on pin 12? This is kind of what I did. But I didn't have it like this. So you have number 2. And yep, that's kind of how you do that. But what if I have 3 or 5 or 10? I don't know if I'm going to have 10 LEDs though, but still. It could be an LED and then you can have LED and piezo. And you can go like that, but for now we're just going to keep it simple and have 1 LED. Next time we're actually going to do something similar. The wires are going to be one thing different. The codes are going to be I think it's 3 things different. No, 2 things different. Yep. It's quite easy. But I'm not going to tell you what it is yet until you watch the video. Because that would just be revealing what's happening next. And that would just be, then it would be boring to watch the video. Why would I say what it is? I'm not gonna. That's why. So, what we're gonna do here is we're gonna go pin mode. There's a function. So I already explained what a variable is just now. And a function, though, it's actually going to be good for you to know that variable thingy right now. A function, if I had a function, you write void. Well, it could be int or whatever. That's just what it returns. Void means nothing. It's not 0, not anything. It's just nothing. So you can have a void, which is actually what most functions are, unless you're having a variable. Int 1 equals 1, and this returns turn 1. This is actually kind of the same thing as going int 1 equals 1. These are kind of the same thing, but don't do it, because if you verify it, let's actually save this. We're going to save it as blinking underscore LED. If you leave a space, it'll automatically replace it with an underscore. So if you want to put your dashes, if you like dashes instead of underscores, put dashes. If you like pluses or whatever, put them there for now. Some of the symbols don't work. It'll just replace it with an underscore. So we'll do blinking LED like this. Oops, and as you can see, it says redeclared as a different kind of symbol. So if you want to do this, and you want to have this kind of one, and this kind of one, you can go like that, positive, and that's going to verify and work. But no, 2 things cannot be the same, even if it's a function or a variable. Int 1 equals 1, int 1 equals 2, not going to work. We declare, if you want to change 1 to 2, go like this. You just give in the name equals 2. Instead of giving it the data type, because it already knows the data type. So we verify it now. 1 does not have a name. What? Here, 1 does not name a type. Oh, you can't put it in here. You need to put it over here. And then you can run it, I think. Oh, I understand. It thinks it's tone. That's a different one, but we'll get into that stuff a little later. Well, that's how that works. And pretty much what a function is I can have 1 and my function. That's a function right here. And then you put 2 parentheses. And if you want the function to know something, like if there's something that you want inside the function that the function doesn't know yet, you can make a variable inside here, but you still do need a list of data type. So number, if you have a number that it needs, you can go int number 1, or you can name it whatever you want, int pin or whatever. You can do like that, and then you write the code in here. And the thing is that if you ever go my function, you're going to have to give in that. If you don't, you can go equals 0. That means automatically it'll be 0, or equals 5 automatically. And the same thing if it's a string, which we'll get into in another video. Actually, we'll get into it now. String. And string, and then you can have a name, for example, the word 30. String word 1 equals whatever it is. And actually, word is a data type. You can go my word equals, and you can have equals like this and then go like that. And what if you need a word and a number? You can have this and then go like that. You just put a comma between them, and then every time you call it, you don't even need to give it in. So you can have word, we'll just do string, and I'll do my sentence. I don't think sentence is a variable, right? Sentence is not a variable, unless I spelled it wrong. And if we have it like this, you need to give in the sentence. Let's just have, you are cool. And that can be your sentence. And then we can verify it and it runs. But if we go equals, you are cool, then you don't even need to give that in. That means it's, oh, yeah, my IDE sometimes does do little funny things, especially because there's a newer version, and that there's just running my computer too, which is a little bit annoying, because I also have a Mac, and they're quite expensive. But here, you can do that, and then you can give in the sentence, you are cool, and it doesn't need to be you are cool, it can be whatever. That will still work, but my computer's still acting silly. You can stop acting silly at least. You can act weird, but don't act silly. Alright? So, if that ever comes, you can also press Command S to save it. That way, it still will have the message, but it won't have that red line, which is a little bit annoying. Especially if you have some kind of pin mode like that. Verify. It might be a little hard to see. Wait. Oh, that works. That's a little weird. I didn't know that. So we'll go pin mode, which is the function that we were gonna call. And this is actually how you call a function. And this function comes with Arduino. Like there's other functions that come with Arduino too, like delay and so on, random. But pin mode is one of those functions that come with Arduino. So we want to have the LED to be pin moded, if that makes sense. So LED, and then you say if it's an input or an output. Output means that data is getting sent out, like to the LED. Input means that the other thing is telling us. So if the LED would be telling us to turn on, even though it doesn't do that, you would write input. Now, if we tell the LED to turn on, which actually happens, you go output. So that means input means that the data is coming into the computer. Output means that the Arduino is sending it out, or the computer is sending it out. It's kind of the same thing. So output. That's actually what happens. The Arduino tells the LED to turn on or off, right? Or does the LED tell the Arduino to turn on or off? Or do something? No, I don't think so. Unless you have a weird LED that does that. But that's not what a normal LED will do. So then, I'm going to already explain what the delay function does. Because it's also good to give the computer a little rest after going through this. You go delay, which means you wait for a little bit. And you're probably thinking, well, if you want to wait 1 second, you go 1, easy as pie. Now, we use milliseconds. So, 1 millisecond equals 1/1000th of a second. Now, that means that 1,000 milliseconds equals 1,000/1000ths, which is the same thing as 1, because that is a full, let's say, complete fraction. But, yeah, some people don't call it like that. Anyways, 1 second, or 1,000/1000th of a second. Now, if it's like this, that means the same thing would have to go the other way. 1 second equals 1,000 or 1,000 ones milliseconds. Now 1,000 equals 1,000 ones, of course, but we're not doing fractions right now. You should know what fractions are by now, but if you don't, that's okay. But it will be a very useful and handy tip to know that when you're doing coding. So it's a good idea to know fractions, especially how to turn a decimal to fraction, because that's one big thing that might happen a lot, actually, to me. So that means if we want to delay 1 second, we gotta go 1,000 milliseconds. So that means also if we want to go 0.5, 0.3 milliseconds, which now we're going to convert a decimal into a fraction, equals 3 hundredths. And if we want to turn this into thousands, we multiply the denominator by 10, and then we also got to multiply the numerator or by 10 to keep the fraction the same. So that's something I just learned in school, actually. So we do this, and I'm gonna leave this here. Well, actually, no, not these. I'll remove that. But yes, that means 31,000. So that means we need to go 30 milliseconds. Even though that means we're gonna have to go 300 actually. It really doesn't make sense, but still. Just trust me. This is what 0.3 is. So, because if we're trying to convert a fraction back into a normal number, we're not going to do that right now. Just trust me. 300. So 0 point, and then you give in 0.7, 0.3, 0.1, 0.8. Just give it in here. Then go 3 zeros and remove the 0 point. So if we have 0.3, that means we need to put in 3 zeros after it, and go ahead and remove those that 0 and the dot. So that's how you do that. Next, we are going to go down here, and we're going to go digital write. This makes sense to you, hopefully. Digital pin, and you write something to the digital pin. It's kind of like you have your cell phone, and you're telling the digital pin 13 here, which is actually what we're going to do, 13. But since we already have a variable that holds that, which is called LED, we just go LED. So let's say we have digital pin 13, which is actually called LED on a smartphone, and we say turn on or turn off. Then it receives it, and it's like, okay, and it does its job to turn on. So to do this, now you'll see that it's on here. You'll have on like this instead of high. That's because on is the same thing as high. And the reason why it'll be on is because we have that variable there called on, like that, and then every time we call that variable, that's the same thing as high. But we're not going to do that right now. We're just going to go normal, high. Then we're going to go delay and give in how many milliseconds. So if we want to wait 1 second, how many milliseconds is 1 second? Think about it, okay? Got the answer? Okay. If you don't, then go ahead and pause the video and think some more until you find the answer, which is 1,000 milliseconds. Okay, because 1 second, it actually says it right here, equals 1,000 milliseconds. You can also just give in whatever, 1, which is right now the number, and you go times 1,000. So the amount of milliseconds times 1,000. This here is the formula. 1 times 1,000. These are actually the seconds. So seconds times 1,000. And that's how many milliseconds it is. And that means that if we want to do the opposite, since multiplication and division are inverse operations, which you should know what those are by now, too, you can go, instead of doing, to turn the seconds, to turn milliseconds back into seconds, you can go the milliseconds divided by 1,000, right? So if we have 1,000 milliseconds, or 2,000 milliseconds divided by 1,000, that's 2. So we have mils, which is short for milliseconds, mils times 1,000. That's what it really is. So that's a good trick for figuring out. But now we're going to go ahead and finish off this. And don't forget you put your semicolons after this code. I wasn't even used to it a bit. Not even I remember when the first program I wrote, I see 100 errors down here. Semicolon missing, semicolon missing, semicolon missing. I know if you have it, it's normal, but still, sometimes I still forget it. And sometimes if I'm writing a different programming language, like Python or Swift or Objective-C, since there's no semicolons, it's like, what's that? And I write it, and then I'm like, oh, forgot, delete it. Sometimes even after 10 lines, then I'm like, oh shit, I'm not writing C++. And sometimes even I call functions in C++, and instead of going def loop equals something, I sometimes even do curly brackets because I'm so used to doing curly brackets instead of colons in Python. So yeah, we'll learn about those languages later on, I hope, if you're still sticking around. On the wall, stuck on the wall. No. Then we'll get into those languages too. And we'll go digital right. And then, of course, we're going to give in LED. But now we're going to go off. What's off again? I think that was low. I think so. So we go low. Who's forgetting semicolons, mister? I almost forgot it. So I go delay. And then I go 1,000, of course, because semicolons. Digital right, LED high, delay. So this means turn on the LED. I'll actually put the comments here. Turn on LED. Wait for a second. Turn off the LED. Wait for a second. Then we repeat it. That means turn on the LED, wait for a second. Turn off the LED, wait for a second. Turn on the LED, wait for a second. Turn off the LED, wait for a second. I could say that all day if I wanted to. Even maybe for a year. If I wasn't asleep. If I wouldn't, but still. So what I do here, I think I would be able to do it for a day though. I'll try doing that tomorrow actually. Of course not. Why would I do that? So turn on the LED, wait for a second, turn off the LED, wait for a second, and look, while it's waiting, the LED is still on. And then we have here, LED is still off. So that's how you do the code. Now we're going to go ahead and press that upload button to upload it to our Arduino. Hope you guys are ready. Let me go ahead and plug everything together, because I think I lost track. How do you wire it again? Let me go watch my video. So, in Tinkercad, I'm here, and I can open up the code window and paste in my code, or I can write it all over again. Then, I can also go into the Arduino window and press the upload button. once my Arduino is plugged in. So what I'm going to do is I'm going to go into the code section and paste it in. See you there. So I can open up the code window here, and I pasted it all in. I copied it from the other window. So I can start the simulation, or you can press the upload button, and this should be working. If not, please make sure that all the wires are connected. I can stop the simulation after.